All right. Hello. We're going to today I'm going to do a quick example of solving a time-independent Hamiltonian to find the probability of measuring some observable. So we're going to follow this problem-solving guide from class and our book, which is given a time-independent Hamiltonian and initial state. What is the probability of measuring some eigenvalue for some observable, which of course is called A, for no apparent reason. So we'll start by diagonalizing H, or finding the eigenvalues and eigenvectors. We'll write our initial state in terms of the energy eigenstates, and then multiply each eigenstate by the appropriate coefficient, and then calculate the probability. So to do that, we are going to look at problem 314 from the textbook, where we have this initial state here, where these A's are the normalized eigenstates of the operator big A that correspond to the associated eigenvalues. And here's the Hamiltonian in that particular basis set. So we're going to figure out what energies are possible and what are the probabilities for each of those energies, and then calculate the expectation value of A, obviously as a function of time. So we are going to we're going to start with part A, which is the possible energies and associated probabilities. So we're going to start by finding the possible energies that we can measure. Those are the eigenvalues of H. So this is step one. Put it here. So step one, diagonalizing the Hamiltonian, that is finding eigenvalues and eigenvectors. So I will, as normal, put all of these boards, I'll put it in our Google Drive so you can find it. All right, so we'll start by diagonalizing H. We're going to take the determinant of H minus lambda times the identity matrix, where lambda is going to be the eigenvalues. So this is going to be 2E naught minus lambda, then E naught, 2E naught minus lambda. And remember that this has to be equal to 0. So to find the determinant, remember we go down this first diagonal and then subtract the product of going back up the off diagonal. So I am going to end up with 2E naught minus lambda quantity squared minus E naught squared equals 0. Or 0 equals, I'm going to square this out, which is 4E naught quantity squared minus 2 times 2. So this is 4E naught times lambda plus lambda squared minus E naught squared. So 0 equals 3E naught squared minus 4E naught lambda plus lambda squared. This is equal to, if I factor it, E naught minus lambda times 3E naught minus lambda, 0. This is my characteristic polynomial. So I have two cases. Case one is when lambda equals E naught. So I am then going to find the eigenvector associated with this particular case. So if I look at my cases, 2E naught minus E naught, E naught, E naught, 2E naught minus E naught, times the vector A, B, I should get 0. So I'm going to factor out the E naughts just to make life a little easier. This is 2 minus 1, which is 1, 1, 1, 1, times AB equals 0, or A plus B equals 0, or B equals minus A. So this means that the eigenvector associated with E naught is proportional to 1 minus 1. To normalize this, this is just the 1 over square root of 2 out front. 1 minus 1. So this is the eigenvector for the eigenvalue E naught. Case 2, lambda equals 3 E naught. This time I look at my values here. I have 2 minus 3, 1, 1, 2 minus 3, times the vector AB equals 0, or E naught is minus 1, 1, 1, minus 1, AB equals 0, or minus A plus B equals 0, or B equals A. So this is the eigenvector, oops. This is the eigenvector of 3 E naught is proportional to 1, 1. So this, the normalized version here is 1 over the square root of 2, 1, 1. So now we have the eigenvectors and the eigenvalues. So next we could then to find the probabilities, we need to move to step 2. Step 2 is to write the initial state in terms of the energy eigenstates. So I know that my initial state, psi of 0, is given as some constant c times 3a1 plus 4a2. All right, so I need to find c. I know that if I take the inner product of the state, that it needs to be normalized. So this needs to be equal to 1. This is equal to the absolute value of c squared times then 3 times 3. So 9 inner product a1 plus 16 a2. This is 1, this is 1. Well, I've skipped over quite a few steps, obviously, but 1 equals the square of this constant squared, 9 plus 16, which is 25. So c squared equals 1 over 25. C is going to be 1 over the square root of 25, which is 1/5 here. Which means that I can write my initial state, oops. I can write my initial state as 1/5 3a1 plus 4a2. So good, now I know psi naught. Now I can calculate part A, which was to find the original energies of these different things. I'm going to write this in matrix notation, so represented by the column vector 3/5, 4/5. All right, so the first question is, what is the probability of measuring the value E naught? That is going to be the absolute value of the inner product of E naught, the eigenvector E naught, with psi at time 0, all squared. So this is equal to then E naught, remember that had a 1 over the square root of 2 out front, 1 minus 1. They're both real, so I don't have to worry about any complex conjugates. 3/5, 4/5 quantity squared, so that this is 1 over the square root of 2 times 3/5 minus 4/5 quantity squared. This is 1 over the square root of 2 minus 1/5 quantity squared. When I square it, I'm going to get the 1/2 times 1 over 5 squared, so that's 25. And this then becomes 1 over 50, or 2%. So there's a 2% chance of measuring E naught at t equals 0. Let's find the probability of measuring 3 E naught, which I hope is 98%. Just, FYI there, right? That's what we would hope. 3 E naught psi of 0 squared. So this, of course, was still this 1 over the square root of 2, 1, 1, 3/5, 4/5 quantity squared. So this then becomes 1 over the square root of 2, 3/5 plus 4/5 quantity squared, or 1 over the square root of 2, 7/5 squared. So this becomes then 49 over 2 times 25, or 49 over 50. And this is indeed 98%, as expected. So fortunately, these two probabilities add up to 100%, which is good because of the only two energy levels I have. The particle has to have one of them. So this is the end of part A. We're now going to move to part B, where the goal here in part B is to calculate the expectation value of A as a function of time. All right, so we will start with step 3, which is to multiply our psi naught by these e to the minus I e sub n t over h bar terms. All right, so let's go. We have, remember that psi of 0 is equal to 3/5 A1 plus 4/5 A2. Now, there's another way of writing this, all right, which is to look at then, I could write this in terms of the energy eigenstates. So this would be psi naught. This would be equal to E naught times psi of 0 in terms of the E naught stage, plus then the overlap of 3 E naught with psi of 0. Along 3 E naught. So I have to write this in terms of the energy eigenstates in order to do my multiplication factor. So if I look back at my previous information, E naught times psi 0, this was equal to minus 1 over 5 square root of 2. This was this particular value here, E naught. Plus, then my 3 E naught, this one was the 7 over 5 square root of 2. These were the values right before I did that squaring. So now I can do the extra term. I'm going to write this one more time because I like to have, when I switch slides, I like to write it all back down again. This is minus 1 over 5 square root of 2 E naught plus 7 over 5 square root of 2, 3 E naught. All right, now I can put in my, my energy terms. So this becomes minus 1 over 5 square root of 2 e to the minus I E naught times time over h bar E naught plus 7 over 5 square root of 2 e to the minus I 3 E naught t times time over h bar 3 E naught. This is psi of t. So this is the time dependent state. All right, there's a little bit more simplification that we can do. We want to calculate the expectation value of A. And to do that, I am going to then look at some easier terms. So what I'm going to do is I'm going to factor out everything in common with both terms to make my future calculations simpler. And then I'm going to rewrite this in terms of the A state. So it's backed in vector notation. So I am going to factor out a 1 over 5 square root 2 e to the minus I E naught times time over h bar out of all the terms. So this becomes minus the state E naught, and this becomes plus 7. I've already factored out one of these, so this becomes minus I 2 E naught time over h bar. This is times the 3 E naught state. So writing it this way is going to make my life significantly easier. Next, I'm going to write it back in the matrix notation. So now I have psi of time, which is equal to 1 over 5 square root of 2 e to the minus I E naught t over h bar. And now I'm going to multiply by minus the E1, or the E naught state. E naught, remember, was 1 over the square root of 2, 1 minus 1, plus, now I had 7 e to the minus I 2 E naught times time over h bar, 3 E naught, which was 1 over the square root of 2, 1 over the square root of 2, 1, 1. Here. So I can write this whole thing. Well, first of all, I have a 1 over square root of 2 in both terms. So I'm going to totally factor that back out. So this becomes 1 over 5 times 2, which is totally about to become 10, e to the minus I E naught t over h bar. And this then is now, I'm going to add all these terms together. So I get minus 1 plus 7 e to the minus I 2 E naught time over h bar. And then I have minus times a minus, that's plus 1 plus 7 e to the minus I 2 E naught t over h bar. So remember that this is the A1 state and this is the A2 state. So this ends up being e to the minus I E naught t over h bar over 10 times this minus 1 plus 7 e to the minus I 2 E naught time over h bar times A1 plus 1 plus 7 e to the minus I 2 E naught time over h bar A2. This is our final time dependence. All right, so let's look at the probability of measuring A1. This is the overlap or inner product of A1 with psi of t quantity squared. So in this case, I'm going to find the expectation value by finding the probabilities and then multiplying each of the probabilities by the eigenvalue. So this is equal to then the absolute value of A1, which is 1, 0, times 1/10 e to the minus I E naught time over h bar, times then my minus 1 plus 7 e to the minus I 2 E naught time over h bar, plus 1 plus 7 e to the minus I 2 e naught time over h bar. This whole quantity squared. I say, well, that's nice. This is going to be fairly straightforward. I get 1 over 10 e to the minus I e naught time over h bar. And then I just get these two, the row column times the row vector times the column vector. And I just get this top term, which makes life much easier. Minus 1 plus 7 e to the minus I 2 e naught t over h bar. And then I'm going to square this mess. All right, let's prepare to, we're going to square now. 1 over 10 times 1 over 10 is 1 over 100. This is e to the minus I e naught time over h bar times e to the plus I e naught time over h bar. So together, these just give you 1. And then I'm going to have minus 1 plus 7 e to the minus I 2 e naught time over h bar times its complex conjugate, which is minus 1 plus 7 e to the plus I 2 e naught time over h bar. Let's multiply this mess out. So this probability of measuring A1 is 1 over 100 times the minus 1 times minus 1, which is 1, minus 7 e to the plus I 2 e naught t over h bar, minus 7 e to the minus I 2 e naught time over h bar, plus 7 times 7, which is 49. So this is 1 over 100. 1 plus 49 is 50. And this then becomes minus 7 times e to the plus I 2 e naught t over h bar, plus e to the minus I 2 e naught t over h bar. Now this term, e to the I stuff plus e to the minus I stuff, is 2 times the cosine of the stuff, 2 e naught time over h bar. So this then becomes 1 over 100 times 50 minus 7 times 2 times the cosine of 2 e naught t over h bar. Just sitting over in the background being judgy. So new page. This probability A1 is going to be 1 over 100, 50 minus 14 times the cosine of 2 e naught time over h bar. This is my final probability. I will use this later to find the expectation of big A. Let's now find the probability of measuring little a2. So this is, of course, the overlap of a2 with psi of t, quantity squared. So this is then going to be 0, 1 times e to the minus I e naught t over h bar, which we know is about to disappear, 1 over 10, times minus 1 plus 7 e to the minus I 2 e naught t over h bar, plus 1 plus 7 e to the minus I 2 e naught t over h bar, quantity squared. So here, just to make my life a little bit easier, I am going to say let beta equal 2 e naught t over h bar, just for personal sanity, just to make my life a little easier, because I definitely have gotten sick of writing all this stuff down. So this becomes 1 over 10 e to the minus I beta over 2, and then I get 0 plus 1, so I get 0 plus 1 plus 7 e to the minus I beta squared. This is much nicer. And then I'll just substitute in my value of beta when I get to the end. So this probability of measuring A2 then becomes 1 over 100 e to the minus I beta over 2 times e to the plus I beta over 2. And this is just 1 times 1 plus 7 e to the minus I beta. Oh, there's the beta. Times 1 plus 7 e to the plus I beta. This is its complex conjugate. So this gives me 1 over 100. This part is just 1, so that goes away. And then I will get this 1 plus 7e to the minus I beta plus 7e to the plus I beta plus 49 here. And this gives me 1 over 100. 1 plus 49 is 50. And this gives me plus 7 times e to the I beta plus e to the minus I beta. And this is 2 times the cosine of beta. So this probability of measuring A2 is 1 over 100 times 50 plus 7 times 2 cosine beta, which is just the 14. So this becomes 1 over 100, 50 plus 14 cosine beta, where beta, remember, is 2 E naught T over H bar. And so now we have all the pieces to find the expectation value of A. The expectation value of A is A1 times the probability of measuring A1 plus A2 times the probability of measuring A2. So it's a weighted average. So expectation value of A is A1 times the probability of measuring A1, 1 over 100, times 50 minus 14 times the cosine of 2 E naught T over H bar, plus A2 times 1 over 100 times 50 plus 14 cosine of 2 E naught T over H bar. So I'm going to substitute, I'm just going to do just a little bit more simplification. So this is 1 over 100 times now 50. That was A1 plus A2 plus 14 times minus A1 plus A2 times the cosine of 2 E naught T over H bar. And this is the expectation value of A. I don't know what A1 and A2 are, so there's no point in going any further than this.